This stitches together everything we built. EPO4's data loading, EPO6's fine-tune, EPO7's metrics, EPO9's quantization, and the shipping moves from EP18 and 19 into one single run. For 19 episodes, we've been pulling the Hugging Face spine apart one bone at a time. A tokenizer here, a trainer there, a quantization config off on its own. Today we put the whole skeleton back together. One Python file, one model. It walks in as a generic checkpoint off the hub and walks out as a fine-tuned, evaluated, quantized, publicly shipped model with a URL anyone on Earth can hit. No new ideas in this episode, just the spine, end to end, in the order you'd actually run it on a real job. Think of the spine as 8 vertebrae and every single one is something you've already seen. Find a model, load it, tokenize your text, run it once to confirm it breathes, fine-tune it on your data, evaluate it honestly, quantize it so it's cheap to serve, ship it to the hub, that's the arc. The magic of Hugging Face was never any one of these steps. It's that the same 5 libraries snap together across all 8 without you relearning anything. So this whole episode is really a victory lap. You already know every move, we're just running them in sequence and watching the numbers land. Step 1. Find. We start from DistilBERT base uncased 66 million parameters, a small fast encoder that fine-tunes on a laptop GPU in minutes. We're not training from scratch, we're standing on a pre-trained checkpoint and nudging it toward our task. This is the whole bet of transfer learning. Someone already spent the compute teaching it English, and we rent that knowledge for the price of a short fine-tune. Step 2 and 3. Load and tokenize. AutoModel for sequence classification pulls the weights with a fresh 2-label head bolted on top. AutoTokenizer pulls the matching vocabulary, so text becomes input IDs and an attention mask. These two always travel together. The same name loads both halves, and mismatching them is the classic beginner bug. Our dataset is IMDb sentiment of the hub. 25,000 training reviews, 25,000 tests, each just text and a label. Step 4. Run once before you train. This is the sanity check nobody teaches and everybody needs. We push one example through the untouched model and read the prediction. It's basically a coin flip right now. The head is random, it hasn't learned a thing, but it confirms the wiring is sound. Text goes in, logits come out, softmax gives a label. If this step throws, you fix it now before you've burned 20 minutes of training on broken plumbing. Step 5. Fine-tune. Training arguments sets the knobs, trainer runs the loop, and the loss curve slides down across the epochs the way it did back in APO5. 3 epochs, batch size 16, learning rate 2f5. This is where the random head stops being random and starts actually mapping movie reviews to positive and negative. Same 20 lines of trainer code you already know. We're just pointing it at our data and letting it cook. Step 6. Evaluate and do it honestly. The evaluate library computes accuracy and F1 on the held out test set, the data the model never trained on, F1 of 0.971. That single number is the one you put on the model card and the one a hiring manager actually trusts because it's measured on examples the model has never seen. A model that looks great on training data and falls over on test data is the oldest trap in the book. Evaluation is how you avoid lying to yourself. Step 7. Quantize. The fine-tuned model is great, but it's fat. We reload it under a bits and bytes config in 4-bit, and the footprint collapses from 13.5 gigabytes in full precision down to 3.9 in Int4. Exactly the numbers from APO9. Same accuracy, a third of the memory. This is the difference between a model that needs a data center GPU and one that fits on hardware you can actually afford to keep running. Step 8. Ship. Push to hub uploads the weights, the config, the tokenizer, and a model card with that F1 baked into the metrics table, all to a public repo. The moment it lands, you get a URL, tef.co ucapstone model, and the spine is complete. That's the whole point of Hugging Face. A model isn't done sitting on your disk, it's done when it's a one-line download for the rest of the world. Let's look at the file. It's one script, 20 capstone.py, split across 4 pages, and every page is one vertebra of the spine you already know. Find and load, tokenize and fine-tune, evaluate and quantize, then ship. No new libraries, no new ideas. We're calling the same functions from the last 19 episodes back to back in run order and printing a check mark as each stage clears. Page 1 is find and load. We import everything up front, transformers, datasets, evaluate. PEFT is skipped since we're going full fine-tune here. Bits and bytes for the quantize step, and Hugging Face hub for the push. Then we name the checkpoint DistilBERT base on cased, load the dataset with load dataset IMDb, and pull the tokenizer and model with the matching auto classes. Num labels 2 for our positive negative head. By the end of this page, the raw materials are all in memory. Page 2 is tokenize and run. We define a tokenize function with truncation and write it across the dataset with map batch true. Then attach a data collator with padding, so each batch pads to its own longest row instead of a fixed max, cheaper and faster. Then the sanity run. One example through the untrained model, argmax the logits, print the prediction. It's wrong, and that's fine. We just prove the pipe is connected before we spend real time on it. Page 3 is fine-tune and evaluate. Training arguments sets 3 epochs, batch 16, learning rate 2e5, and eval strategy epoch. So we get a metric after every pass. We hand the trainer the model, the args, both splits, the collator, and a compute metrics that loads accuracy and F1 from evaluate. Call trainer.train, then trainer.evaluate, and the held out F1 comes back at 0.971. 2 stages of the spine cleared in one page. Page 4 is quantize and ship. We build a bits and bytes config with load in 4-bit and true, and reload the fine-tuned model under it. The footprint drops to 3.9 gigs. Then log in with the token and push to hub, capstone model, on both the model and the tokenizer, with the F1 written into the commit. The last line prints the spine complete banner with the F1, the endeavor size, and the live hub URL. And that's the whole thing. Find, load, tokenize, run, fine-tune, evaluate, quantize, ship. The complete Hugging Face spine end-to-end on one model. You can now find, fine-tune, and ship any model on the hub. Course complete.